Okay, so today I'm going to talk about an introduction to area. So area is brand new to us, and introducing it means we're going to know it. So we've talked before about what the word introduction means. Like, hi, nice to meet you. My name's Mr. So. So that's what we're all about today. Hi, nice to meet you. This area. Our goal today is to find the area of a shape in square units. So we are going to be looking at shapes, but specifically we're going to look at these shapes. So do you know the name of those shapes? This one is a rectangle, right? And this one is a square. The difference between a rectangle and a square is what? They both have corners that are shaped like the letter L, and they both have four sides, but what makes them different is the length of those sides. On a square, all four sides are equal. So we're going to go ahead and get started. So area is when we find out how much space a flat shape covers or takes up. Today we're going to talk about finding the area of shape. And you guys know flat shapes. Have you heard of 2D? You know how 3D is like when you go to the movie and you wear the glasses and everything pops out at you? Flat shapes are 2D shapes. And area is how much space is inside of a 2D shape. So there's a video. I'll attach it to the assignment for today, but we're not going to watch it in my video. So when would you need to find the area? One time that we might need to use area is to find out how much paint we need to cover a flat inside of a space like a wall. So if we're painting a wall in a room, usually our walls are rectangular or square, and since we want to cover the entire inside of the wall with paint, all of the space inside, we need to find out how much space is inside our wall. When would you need to find area? You might need to find area if you were laying tile in a room. So if you look at our classroom, it's covered in these square pieces. These square pieces are called tiles. And when we are talking about area, we say that each tile is a square unit. Notice that the tiles that he's holding are squares, and if you look at our floor, these tiles are squares also. So when we measure the amount of space inside of a shape, we say it is 12 square units, or however many squares it takes to fill the space. So we need to find area. Another time you might need to find area is on sod or grass. So I don't know if you know this word sod, but it's a new word that's going to come up a lot during our area lessons. And sod is, I don't know if you can see what they're doing, but see how he has in his hand? They're laying down squares of grass. So sometimes if you see a new house being built, you'll notice that the dirt outside the house, now the dirt area here, okay, the dirt outside of the house gets covered up with squares of grass called sod. So you can call these sod squares tiles, and each grass tile is, again, a square unit. So square units are what we're going to use to measure the amount of area inside of a shape. So which shape has the biggest area? Now, if we're looking at shapes, we really can't tell because there are no square units for us to count. So let's see about this picture. What if we had this paper? Could you determine which shape has the biggest area now? Yes, you could. What you can do is you can count the squares inside of each shape. To find area, you count the unit squares, so each square is called a unit square inside a shape, and that's going to tell you area. This shape has an area of 16 squares or 16 square units. And you can count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this shape has an area, which I sometimes just write A, of 16 square units. And guess what? Write it shorter. 16 square units. Pretty easy, right? Everybody knows how to count. We can count. One thing you'll notice as they were counting these, they wrote the numbers inside the squares. Makes it a little easier to keep track of. Unfortunately, so now let's compare these shapes and let's count unit squares inside each shape to see which shape has the largest area. So let's look at shape A. Count with me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So shape A has an area of 24 square units. How about shape B? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So B is 20 what? 20 square units. If you're not saying square units, then you're not finding the area of the shape. Okay, let's look at C. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So C, that's 24 square units. Oh, ugly handwriting. 24 square units. Let's look at D. And then we'll just have one more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Unit. Last one. Define your color. How about purple? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you'll notice, like with shape, it is possible to find the area of shapes that are not rectangles and squares, but it's a little trickier if there are not unit squares inside of the shape. So this was 11 square units. So take a look at these numbers again. Which shape had the greatest area? Looks like we have a tie. A and C. They both had an area of 24 square units. So, which shape has the biggest area? Even though they're different shapes, this one is a rectangle, and this one is kind of an L shape. They have the same area. Shape A has an area of 24 square units, and shape C has an area of 24 square units. So we can say that the area of the shapes is the same or equal. The area of these two shapes is equal to one another. So again, we have a little reminder that you cannot forget to label your answer with the area. Okay, so when we look at the example here, we'll see that these shapes aren't measured in units but in inches, and so we say that the shape is 1, 2, 3, 4, 5, 6, 7, 8 square inches. 8 square inches. One thing that we are going to be learning about, right, is that unit squares must be the same size, and there can be no gap or overlap in our unit squares when we're using them to measure the area of a shape. So for example, it says, which shape below shows unit squares used to measure area? Well, number one, are these even squares? No, they're not. These are little triangles. Number two, we do have squares here, but we have a problem, which is what? Can you figure it out? What's wrong with these squares? How about the fact that they're not equal? You can't use unit squares to measure shapes that are not equal. C looks pretty good. I'm going to give it maybe. Those are our unit squares. They're all equal in size. There's no gaps or overlaps. And then D, we see number one, we don't have squares. And number two, they're not equal. So not square and not equal, which means these are not the unit squares we're looking for. So if we wanted to find the area of one of these shapes, the only one we could find is this one. It's 1, 2, 3, 4, 5, 6, 7, 8, 9 square units. Okay, square units. We need to use this when we measure area. And find the area. We'll just do, let's skip ahead here. You guys know how to, oh, let's look at these. So one thing sometimes are shapes like this and they want you to find the area. This is a little bit annoying. You have to use your imagination to connect the dots. So let's change colors here. So this has already got unit squares, right? Our squares are connected by these little lines here, and it makes it easy to count them. But in this shape, we have to connect the dots ourselves. Now, we don't want to connect dots like this because this is not a unit square. This is a triangle. So instead, we're going to connect the dots this way. We're going to kind of go across like rows, and then we're going to go up and down like columns to let us find the area of this shape. So now my shape has squares, and I can find its area. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So my area is 12 square units. Okay. Have this one, another connect the dots situation. So we go across kind of like rows, we connect the dots to each other, and then we're going to go up and down and connect our dots like columns. And this is going to give me the squares that I need to count. Maybe not beautiful squares, but close enough, right? Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 square units of shape. Oh, look at that. So it looks like this shape and their areas were equal to each other. Remember, that one was 12. So again, you can find the area of this shape, how you would count the unit squares inside the shape. You notice how I say that we count unit squares? But when we find the area, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. So I say that we count unit squares, but I would say the area is 40 square units. Why do we first say unit squares and then like flip-flop it and say square units? I don't know. Just a weird math. Remember, I didn't teach it. Find your Is there anything else here? No, we're not going to do that. Let's look at this. Okay, which of the following is a unit square? So this is important. When we find the area, we count unit squares. And unit squares are special squares. They're not just any size square. A unit square's measurements are always 1 on each side. Okay? Now, it could be that each side is 1 unit. It could be each side is 1 yard. Each side is 1 foot. Each side is 1 inch. Each side is 1 centimeter. Each side is 1 mile. It doesn't matter, but what does matter is that the unit square has each side being 1. So if each side has to be 1 to be a unit square, each side is 1 whatever, we'll say 1 foot for this example. Each side of the square is 1 foot. Okay, so can A, is this a unit square? No, it's not even a square. And one of the sides is 3 yards. So A is not the answer. B, no. This is a square because the sides are equal. See, this side is 3, this side is 3. Okay, and guess what? This side's probably 3 too, and so is this side. But a unit square has each side being 1 unit. So each side should be 1 yard in this case. And it's not. So that's not a unit square. Now C looks pretty good to me because it is a square. It looks like a square. This side is 1, which means that the other side across from it is probably 1 yard. And this side is 1, which means the other side across from it is probably 1 also, which means that this is my unit square, I believe, because, sorry, it's annoying, because each side is 1 and unit squares have each side being 1 unit, whether it's 1 yard, 1 foot, 1 inch, whatever. I think it's my answer, but let's check out D. Okay, D doesn't make any sense because it says this side is 3 feet, this side is 3 feet, but this side's long and that side's short. I thought they were equal, and it's a rectangle, not a square. So I'm going to say no, not my unit square. Okay, so this was my only other square on the page, and I knew it wasn't the answer because unit squares each have each side 1 unit. Let's see about the last question. Okay, select one that shows a situation where you can find it. Let's ask these kind of questions, and you have to think, am I measuring the inside of whatever? Okay, because area is all about measuring the space inside a shape. Okay, so determining how long a snake is. No. We can use a ruler to determine how long a snake is, but area is about measuring space inside of a flat shape. So I'm going to say no to the snake. I don't think so. B, determining how large a frame has to be to go around your picture. You guys know what a frame is, right? Like you have a cute picture of yourself and then there's a frame around it and it's pretty. Does that look like a frame? Not really. No, we don't want to know around. We want to know how much space inside the shape. Determining how much grass you have to cut in your backyard. Remember back here? Grass, sod, grass. We talked about this. They love to talk about sod and grass when finding the area, the shape. So I'm going to say yes to this one, because they want us to find out how much grass you have to cut, and that's how much space on our flat yard that we want to measure. Determining the amount of books to read, no. We don't need a ruler or anything to figure that out. You don't have to measure anything. So I'm going to say my answer is C. So if you have any questions, you can go to your lesson, and I'll post a link to this video in the lesson, and you can watch that too. And I hope you have a great day.